We're going to look at two very common special cases of logarithms, and those are called common log and natural log. And before we do that, I want to remind us what a logarithm is. So if you have this expression a to the x power equals y, remember a is what we call our base, a to the x power, x being a variable and an exponent here. So another way of saying a to the x power equals y is through a logarithm. The log base a of y equals x. And so the way you have to think about a logarithm is, so these kind of questions are complicated because we have a variable exponent, right? X is an exponent. The reason logarithms are helpful is because it takes the variable out of the exponent, like we see here, where the x is now taking out of being an exponent. And the way you have to think about it here is you ask yourself, what power of a is y? And the answer to that is x. Okay, so for example, if you saw log base 2 of 8, I think what power of 2 is 8? The answer is 3. 8 is 2 cubed. So now common log is what we're referring to as a base 10 logarithm. So you may see log base 10 of x. Another way of writing that is just log x. So if there's no base written, it's understood to be 10. So when you ask yourself, what's log of 1,000, for example, what I'm asking myself here, I didn't see a base, so I understand the base is 10 because it's a common log. What power of 10 is 1,000? And the answer to that is simply 3. Okay, so if you see on your calculator a log button, for most calculators, log just means log base 10, common log. Okay, now the other one, natural log, is base e. Now remember, e is this exponential number, and it's around 2.718, and it's irrational, so it keeps going on from there. E shows up a lot when you're modeling population and decay and things like this, so it's very natural to talk about it, and we call it natural log. So log base e of x, we don't write that usually, we write ln x. This comes from the French expression for natural log. I say ln, some people say ln, I like to say ln x. So if you had something like this, ln e to the fourth, remember you have to ask yourself, what power of e is e to the fourth power? Well, of course, e to the fourth power is the fourth power of e, right? So ln e to the fourth is 4. And you can see on your calculator, there's a ln button as well. And these are the two types of logarithms that show up on almost any calculator. Now to understand common and natural log a little bit more, I'm just going to do a few examples. Okay, so for here for my example, I want to evaluate the following, and for a, I want to evaluate ln of the 7th root of e. Ln of the 7th root of e. Okay, now if we remember that the 7th root is the same thing as saying e to the 1/7 power, I think this makes a lot of sense, because remember when you see ln, that means log base what? It means log base e. And again, you have to ask yourself, what power of e is this expression in the middle? Well, e to the 1/7 power is the 1/7 power of e. So this equals 1/7. Okay, so for part B, we're trying to evaluate log of 10,000. And so I need to think about what power of 10 is 10,000, right? Because I don't see a base, so I understand that this is a base 10 situation. This is common log. And there's a couple ways to think about it. One is I can think of 10,000 as 10 to the 4th power. So what power of 10 is 10 to the 4th? Well, 10 to the 4th is the 4th power of 10. So log of 10,000 is 4. Now an easy way to do that, if you have a power of 10 and you're trying to evaluate log of that, is just count the zeros. There's 4 zeros, so it reduces down to 4. Okay, now from example B, you could see how if I'm taking something like this, I'm taking log something, I can put in really big numbers like 10,000 and get a really small outcome of 4. Okay, so where this is useful is where you have just a small change leads to drastic changes. You can use a logarithmic scale to make those drastic changes not seem so big. For example, log of 1,000 is 3, log of 10,000 is 4. 3 to 4 represents a huge change. Okay, but those numbers are manageable. Okay, now parts C and D, we're going to just practice plugging these into our calculator. Okay, so we have ln of 4.78. Now the reason I know I have to use a calculator for this is because 4.78 is not, I don't recognize that as e to some power. Okay, so I just plug in my calculator. In some calculators you have to put in 4.78, then you hit ln. Some you hit ln and then 4.78. So you need to make sure you practice this. Students don't think they need to practice using their calculators, but you really do. So if you plug in 4.78 in the ln, you should get about 1.564. Right now, part D, I'm plugging in ln of 10.5. Now let's think for a second. What power of 10 is 10.5? I don't know exactly, but it's a little bit bigger than 1 and it's less than 2. So I believe this answer is going to be somewhere between 1 and 2. And when I plug in 10.5 into the log function in my calculator, and again, you might have to type in 10.5 then hit logarithm, or you hit log and then 10.5. Make sure you get this answer. You should get about 1.021. And that's it. Make sure you hang on to the fact that if you don't see a base, you know it's log base 10, and if it's ln, it's log base e. Those are very important. If you have any questions on this, I'd be glad to help, and thank you for watching.